Greetings to all of you. In this session, we are going to discuss about the chemistry which is related with the entrance examinations on the international level. In the national level, JEE Advanced and JEE Mains, NEET Chemistry, Telangana EAMCET examination, Andhra Pradesh EAMCET examination, and also for any competitive exam if you are aspiring for. For all these chemistry questions are very much helpful, and these are retrieved from the previous year question papers and solved in a well explainable manner, so that it will be very much helpful for you. Let's go with the question number 1. Water-based liquids can be described as acidic, neutral, and basic with respect to pH. Which of these describes milk? So here, any kind of substance with respect to pH can be categorized into either acidic, neutral, or basic compound. In this regard, what is the category of milk? Milk is taken into the consideration. Either it may be acidic, neutral, or basic. What kind of classification we have to give in accordance with the pH? The options are provided: slightly acidic, strongly basic, neutral, slightly basic. Milk does not have any pH. As everybody aware that milk is accompanied by lactic acid. Because of the presence of lactic acid, slightly acidic nature is imparted for that one, and the pH resides in between 6.7 to 6.9. This is almost near to 7, that is a neutral compound, but less than 7, that's the reason why we can say slightly acidic is the relevant answer for this one. So milk can be stored for longer time by pasteurization, and that can be stored in cans and even under dry conditions, so that it is regarded as slightly acidic in nature due to the presence of lactic acid. And this is called a pH scale, where you can find the values are ranging from 0 to 14. If the values near to 0 or near to 1, we can say these are strong acids in nature. And if the pH is at 7, that is said to be a neutral compound. If pH is near to 14, that is a strong base. So in this manner, on the pH scale, the values are ranging from 0 to 14. So near to 0 are called strongly acidic, near to 7 called neutral, and near to 14 are strongly basic in nature. In this table, if you observe, the milk is near 6.7 around, so that milk is regarded as slightly acidic in nature. And the remaining all are gastric juice called hydrochloric acid is around 1, so that strongly acidic our stomach pH will be. If you go with this what drain, so drain cleaner where pH will be 14, so that will be strongly basic in nature. pH is regarded as a negative logarithm of H plus ion concentration. So this is the way you can mention pH scale. Let's go with the question number 2. DNA codes for proteins. So DNA will give the code, and that code used to synthesize the proteins. So this proteins are regarded as building blocks of any kind of organisms. What is the most abundant protein in the human body? Right. So here DNA is very essential for the synthesis of protein based on its coding system. And here you can find the triplets in the DNA, which are used to synthesize this protein. Protein synthesis is purely possible because of DNA coding system. And according to that one, which kind of protein will be synthesized in the larger extent, and that will be abundant in nature. So options provided are tubulin, albumin, collagen, keratin. So from these we have to predict the right answer, that will be a collagen. So keratin is a kind of protein which is present in your hair and nails. Hair and nails can accompanied by keratin, and these are having tendency to grow forever. Even the organisms are alive or dead, that hair and nails always can grow. That is here accompanied by the protein called keratin, right? So this is also the kind of abundant protein, but most widely available protein will be collagen only, and this is found in bones and cartilage. Okay, so in bone system you can find this collagen, and it is highly strong and flexible material. Here if you observe, tubulin is a kind of protein, and which get polymerized available in the skeletal system of the living cells. Skeleton of human skeleton is accompanied by this tubulin protein. Albumin is a globular protein which is present around 3.5 grams to 5 grams, which is available especially in the plasma serum in the healthy human. So this is the kind of range of albumin protein in the human being. 3.5 to 5 grams will be there. Collagen is most widely available and it's mostly present in the connective tissue and also bones. Skeletal bones also accompanied by collagen. It is highly flexible material. So keratin is the another protein just to be described about this one. Hair and nails, even skin. Epidermis means outermost layer of the skin is called epidermis. It's also accompanied by the protein called a keratin. Okay, so if any wounds are there and a breaking of nails are there, this keratin will heal them. So it is a kind of healing protein. So the right option will be option number C. Collagen is the correct answer. Let's move on to question number 3. It is collected from the JEE advanced question paper. The number of unpaired electrons in the cobalt complex iron, cobalt Cl4 negative 2. This is a kind of a coordination covalent complex accompanied by the negative 2 charge. Complex ion was taken and you have to predict how many unpaired electrons are present around this cobalt metal. So options are 2, 3, 4, 5. The correct answer will be 3. Unpaired electrons will be accompanied by the cobalt in this complex. Let's see how it is possible. How can we explain this one? Cobalt, the geometry is provided over here, that is tetrahedral in nature. Around the central cobalt, there are 4 set of chlorine ligands will be there, and they are occupying the 4 corners of this tetrahedral geometry. And this tetrahedral geometry of cobalt is having D7 electronic configuration system. Cobalt D7 means cobalt plus 2, that is nothing but 4s to 3d7. If you remove 2 electrons, 4s electrons will be removed and a d7 electron system will be there. In the tetrahedral geometry, in the presence of ligands, the orbital splitting will be in the pattern of Eg is laying at the bottom. T2g orbital energy will be rises with respect to the barycenter. Right. So here Ag orbitals are at the bottom are having 4 electrons because maximum capacity of Ag orbitals are 4 and T2G orbitals are accompanied by remaining 3 electrons over here. These 3 electrons are said to be unpaired electrons, so that these 3 electrons are accounted for this number of unpaired for electrons for the cobalt in a cobalt Cl4 minus 2. That will be option number B. 3 unpaired electrons will be there. Let's move on to question number 4. Magnetic moment of the metal ion 3.87 Bohr magnetons. Identify the metal. This is again the part of inorganic chemistry where magnetic moment also plays a vital role in identifying the metal. So if you know the magnetic moment, subsequently lone pair of electrons are known. Subsequently, you can find out which metal it will be. Okay, the options provided are vanadium plus 3, chromium plus 3, manganese plus 3, and titanium plus 2. So among these 4, vanadium plus 3, chromium plus 3, manganese plus 2, and titanium plus 2, you have to identify which element is having 3.87 Bohr magnetons of magnetic moment. 3.87 contributed with 3 unpaired electrons. That is calculated by using magnetic moment formula, which is called spin-only magnetic moment. Under root n into n plus 2 is the formula. Let's go to solve this one. Magnetic moment formula will be under root n into n plus 2 and magnetic moment is given as 3.87. In order to get 3.87, n value must be 3. 3 unpaired electrons are required over here. So if you observe all the matters, vanadium plus 3. So vanadium electronic configuration is there. The valency shell is having 4s2 3d3. Argon is the noble gas. 4s2 3d3 is the valency shell configuration. 5 electrons are resided. If you are removing 3 electrons, the leftover will be 2 only. So that vanadium plus 3 is accompanied by 2 electrons. Chromium plus 3. If you see the chromium, it is provided 1s2 2s2 2p6 3s2 3p6 4s1 3d2. Total 3 electrons will be there in the outer shell. These 3 electrons taken over here under root n into n plus 2 formula. Let's apply over here. N value is taken as 3 because 3 valency electrons are left for chromium plus 3. Under root 3 into 3 plus 2 is the formula. So under root 3 into 3 plus 2 will become under root 15. It should be taken as under root 15. Under root 15 value is calculated as 3.874 magnetons. This is the actual value provided within the problem, right? Let's go with any other values also. Manganese plus 2 and titanium plus 2. Manganese plus 2 is accompanied with the 5 lone pair of electrons, titanium plus 2 with the 2 lone pair of electrons. So that here 3.87 will be for a chromium plus 3. Let's move on to the question number 5. 1 liter closed flask contains a mixture of 4 grams of methane and 4.4 grams of carbon dioxide. The pressure inside the flask is 27 degrees centigrade. We have to calculate total pressure present in that. The options provided are 8.6 atmospheres, 2.2 atmospheres, 4.2 and 6.1 will be given. Among all, which is the right answer, we have to predict. First of all, we have to calculate the number of moles. Number of moles of methane is equal to weight by gram molecular weight. Weight is provided as a 4 grams of methane. Molecular weight of methane will be 16. 4 by 16, it will be 1 by 4. 1 by 4 can be written as a decimal value like a 0.25. And the pressure calculation for the ideal gas P is equal to nRT by V. So N is the number of moles which is taken as 0.25. R is the gas constant whose value is 8.314 kilocalories. And T will be the temperature provided within the problem, that is 27 degrees centigrade. Centigrade to Kelvin scale, we have to add 27 with 273. It will become 300 Kelvin. Right. So 300 Kelvin temperature will be there, and the volume. 1 liter volume can be represented as 1000 ml. So 0.25 into 8.314 into 300 by 1000, the value will be pressure is equal to 0.62 pascals, right? This is for what? Methane. Let's go with the calculation for carbon dioxide as well. Weight by gram molecular weight for number of moles. Weight is given as 4.4 grams of carbon dioxide. 4.4 is the weight of carbon dioxide. Gram molecular weight of carbon dioxide will be 44. 4.4 by 44, number of moles will be 0.1. Let's apply the formula P is equal to nRT by V. N number of moles is 0.1 and the remaining values remains same. 8.314 is the gas constant, 300 will be the Kelvin temperature, and the volume will be 1 liter. It will be taken as the pressure of carbon dioxide 0.24 pascals. Total pressure, in order to calculate the total pressure, let's take the sum of pressure of methane and pressure of carbon dioxide. Methane pressure is 0.62, carbon dioxide pressure is 0.24 pascals. So that total pressure will be 0.86 pascals. So here conversion factor, you can convert pascals into atmosphere. It will become 8.6 atmosphere, right? So in the last question of the session, ammonia is called a Lewis base because, okay. So here, in order to explain about the Lewis acid base concept, first of all, we have to see how many types of acid base classifications are there. Acid bases are classified in different manner. One is called Arrhenius equation, Arrhenius acid base theory, Lewis acid base theory, Bronsted acid base theory. Different kind of terminology will be there, different assumptions will be there. In accordance with the Lewis concept, how can we say ammonia is a base? In order to explain that one, we have Lewis base must contain 1 lone pair of electrons to release, and Lewis acid must contain 1 vacant orbital in order to receive, right? So whichever releasing electrons called a Lewis base, whichever accepting the electron pair is called a Lewis acid. Whenever Lewis acid base got combined, there is a formation of product is possible, right? Boron trifluoride is the simplest example for the Lewis acid, where 1 vacant orbital will be present on its valency shell. At the same time, ammonia is called a Lewis base, where lone pair of electrons will be there in its valency shell, which are ready to release. So that they're able to form a coordinate covalent bond among these two. And nitrogen is releasing electrons, hence we can clearly say it is the Lewis base. In simple way, Lewis acid is the substance which having tendency to accept the electron pair, and Lewis base is the substance having tendency to release the electron pair, right? So in this context, ammonia is a Lewis base because electron pair donor. So that option number 1 will be the correct answer. So by this we completed the session, and I'm requesting for to like this video, comment about this concept, whatever you observed here. Share this video with the aspirants, whoever actually preparing for the entrance or competitive examination, and do subscribe this session. Thank you very much for your patient listening. Thank you one and all. Have a great day.